Okay, so welcome to everyone who is joining us today for our first lesson for the year in this Math School series where we're going to be dealing with revision for the grade 12 syllabus. I'm Dr. Sareen Rathilal and I'm going to be your tutor or the person who's going to be there to help you and take you through the syllabus starting from term 1 all the way up to term 4. This is an initiative that is made possible by NITEX, the National Institute for Theoretical and Computational Sciences, as well as Absolute X. And I would like to point out that this is an initiative of the Mathematical Structures Research Group that is part of NITEX. So let's talk about what content we're going to be covering today. Well, firstly, let's remind ourselves about what you have covered in term 1. So what have you done in term 1? So your term 1 content, according to the guidelines from the Department of Education, says that you should have covered content pertaining to number patterns. Right, so number patterns. In your number patterns, you should have looked at arithmetic number patterns. What else did you cover? Please let me know in the chat box. You would have covered geometric as well as quadratic number patterns. So these were the 3 types that you would have gained some exposure to. In addition, you not only would have studied the sequences and the patterns in them, but you would have also looked at series, meaning the sum of the elements in these series, in the sequences, right? So a sum of an arithmetic sequence, the sum of geometric terms, and the sum of the quadratic terms from the sequence, and we refer to that as a series. Beyond that, you would have recapped and you would have done more content pertaining to functions. Okay, good. So there are things coming through in the chat box. Thank you for the responses there. Right, so you also dealt with sigma notation. So maybe let's just put a sigma in there so everybody remembers. Yes, and so this was referring to the sum and hence the series. As I was mentioning, you dealt with functions. There were various types of functions that you had recapped on firstly from the previous year's content that you would have learned, and then extended a bit on other types of functions. So you would have learned about your linear graphs, isn't that so? So straight line equations, looking at quadratics, so meaning looking at parabolas, then studying exponential functions, then looking at hyperbolic functions, and also you would have learned about the equation of a circle. So those are the various things that you would have touched on. And then finally, you should be still covering the following right now, and that should be trigonometry. Right? Maybe your school has covered it in a different order, but ultimately we should be covering the same thing. Okay, so over the next 2 revision lessons, I am going to be covering content pertaining to the sections that I've just listed. So what we're doing today is we're going to be looking at some questions pertaining to number patterns and functions. We will see how far we can go with the functions, and then from whatever point we stop, when I meet you next week, Friday, we will then continue with functions and touch on the questions pertaining to trigonometry. Of course, the content in trigonometry that you learned this year is quite substantial, so we will see exactly how far we can go and how much we can help you. Okay, so let's look at questions, exam type questions that one could encounter in the upcoming exams. I see we do have some responses in the chat box, so I'm just going to double check before we move on. Yes, so you've also learned about inverses and logarithms. Okay, wonderful. Perhaps let's also write it in here before we move on. Functions plus inverses. Okay, so we will touch on these. So thanks for those responses. I look forward to getting your feedback in the chat box. Right, so what I've got here is a question that has appeared in the I think this was the year-end examination. So this is an exam type question. You can see the mark scheme, you can see what the question is asking, and this in essence is going to help us prepare for the type of questions that you could expect in your upcoming exams. So as we answer these questions, I will try and recap as much as I can in the time limit on all of the content that is required for this particular question. Let's consider question 2.1. Right, so question 2.1 says the following. It says that I have the following sequence. The first term is 7, followed by x, followed by y, and the fourth term in the sequence is minus 11. This sequence continues, as we can see, there's an ellipsis. We are told that this sequence in particular is an arithmetic sequence. Now, what does that mean? What does an arithmetic sequence actually mean? Let's see, what are the responses in the chat box? What is a property of a sequence that is called arithmetic? Right, and I've got the first response, and we have a constant first difference. Wonderful. That is precisely what we're looking for. So when I want to talk about arithmetic sequences, of course, we had learned in school that we shall denote a term in a sequence by Tn. So T1, subscript 1, denotes the first term. T2 denotes the second term, etc. So the general description for an arithmetic sequence, what is that given by? Okay, I'm looking at the chat box again. But here, if I scroll below, this is what I want to bring to your attention, because of course you've learned this content in school, and these formulas are going to be provided to you in the examination. So you will have a formula sheet, and the formula sheet provides you with these formulas. So what is the first formula representing? Can someone tell me? So this formula, Tn equals to A plus n minus 1 multiplied by D. What is this? It turns out that this is actually the general term for an arithmetic sequence, isn't that so? And that is precisely what we require when we're working with above. So thank you for those responses. I see many of you have put in the answer in there. So we have that Tn is precisely A plus, open bracket, n minus 1 into D. Of course, we know what these things represent, isn't that so? So firstly, the n is a natural number, allowing us to work from T1, T2, T3, and so forth. A refers to the first term in the sequence, isn't that so? And D refers to the common first difference that you had all pointed out at the beginning. So I'm just refreshing our memory here pertaining to this general formula. So now let's look at what the question says. The question says, determine the values of x and y. So now I want to solve for x and y. That is what I want to do. How do I go about doing this? Well, firstly, let's make some observations. A denotes the first term. And what is the first term in our sequence? Clearly, the first term is 7, isn't that so? So I've got that A equals to 7. So in order for me to write down a general formula for this arithmetic sequence, I already have A. So the thing that I actually have to solve for, if you can all observe this, is I actually only have to solve for D. Do you observe that? D is the unknown. Okay, and so that is what we are now going to be doing to answer this question. We are going to spend time solving for D. Okay, so I do see that we're getting some responses in the Q&A in the chat box. What I will do is I'll discuss this question, and then afterwards I will come back and I will review any comments or questions that you have posted. Okay, so let's answer. I'm now answering question 2.1. Oops. I need a pen, not a highlighter. So I've got question 2.1. I've got my sequence 7, x, y, let's scroll back up, minus 11. I know that the sequence is an arithmetic one. I also know that A equals to 7. And what I want to do is I want to solve for D, which is my unknown, right? So that's the idea in here. Okay. What else do I know? is happening in here? So firstly, I know that this is T1. I know that this is term 2, T2. That is T3. And 11 is T4. So I have A equals to 7, which is obviously the T1. And I know the value of T4. So let's expand on what T4 represents. Okay, so I observe that T4, according to the general formula that we know, is equal to A plus N minus 1 into D. So since N is 4, it's 4 minus 1, which is 3 times D. Wouldn't you agree? And then, of course, I know that T4 is minus 11. And I know that A is 7. So I've got that minus 11 equals to 7 plus 3 times D. So can you see from this equation immediately, I can now solve for the unknown, which is what I wanted to do. So I can now get out the answer for D. So just performing some operations on both sides of this equation, I then observe that, therefore, it is now clear. Okay, so if I subtract 7 from both sides, I get negative 18 equals to 3 times D. And therefore, I get that D equals to minus 6. Do you agree? Let me now come to the chat box. Okay, various questions. Let's look. We have people solving for X. Let me just observe what is going on. Okay, lots of thumbs up. So that seems everybody is following. So I'm glad that we're all happy with that. I see that someone's expressed the D as X minus 7. And yes, why is that the case? Why can I express the difference as X minus 7? Of course, because the first difference D should be X minus 7. Likewise, the difference should also equal to Y minus X. So that's a very good observation. This could have been a way for us to solve it. But if I started solving by equating the differences, you would have observed that there would have been too many unknowns. There would have been an unknown Y and an unknown X. So in this way, by isolating the equation in this way, by looking at what T4 represented, right, by just dealing with this, you observed that by doing this, there was only one unknown, and therefore I could solve for D. And that is what I wanted, essentially. So now that I know this, we can go back and we can obtain X and we can obtain Y, isn't that so? So let's do that. Right, so we saw that X is term 2. So let's express what term 2 means. T2 is equals to A plus N minus 1, which will be 2 minus 1 times D. So it's A plus D, isn't that so? But that's 7 plus, because the first term was 7, and now I have to add my difference, which is minus 6. So clearly, T2 is now equal to, what do you get? 1. All right, term 3. Well, now, so that was X. I've solved for X. Now I want Y. Y is term 3. Term 3 is nothing but A plus. I'm again using the above formula, okay? So if anybody is thinking about where is she suddenly getting this from, I'm saying Tn equals to A plus N minus 1 times D. So now if I want T3, it's A plus 3 minus 1, which is 2 times D. Okay, and so A was 7, and then I am adding it to 2 times D, which is minus 6. What value do you then get here? This is 7 minus 12, isn't that so? And let's see, I'm coming to the chat box. We've got plenty of responses, and yes, we are looking for a value of minus 5. And that's precisely what we wanted. Or alternatively, you could have thought about it in the following way. Y, you could say, right? We could say that Y is equals to X plus the common difference of 7. So we could have said it's x plus 7, because that's how arithmetic sequences work, isn't that? So you add the common difference to the previous term to get the new one. And so if I'm adding 7 to the previous term of x, x we saw was, oh, sorry, I'm not adding 7. What am I adding? The common difference d was minus 6. So let me just say x plus d, right? And so that becomes x plus minus 6. But we know that we just solved for x and it's 1 minus 6. So that gives you minus 5. So either way, you should come to the same answer regardless of the protocol or the steps that you follow, as long as you do the steps in a very logical fashion. Okay, so are we all good on this explanation for solving for the x and y? Let's check chat box again. Okay, good. Right, lots of responses. Someone's asking, A is given. Yes, it is. So if you joined us a little bit late, here is the original question. We are given a sequence, 7x, y minus 11. There are 4 terms that's in this sequence, and it continues. We're told it's an arithmetic sequence, so clearly the first term is 7. A is 7. And the 4th term, T4, was minus 11. So the protocol we followed was we expressed what T4 represented. We plugged in the A and we solved for the unknown of D. We saw that the common difference was 6. So using the A and the D, we were now able to generate what T2 and T3 were. And that's how we got out what is X and what is Y. Okay, good. How is T2A plus D? That's what someone's asking. Okay, let's investigate. T2 is nothing but T2 is A plus N minus 1 into D, where N equals 2. So therefore, I've got an A, and then 2 minus 1 is 1 times D. So do you see that T2 is A plus D? Are we all clear now? So this is all coming from the general formula of an arithmetic sequence, okay? So remember, we are using the formula from your formula sheet. Of course, there's a way to derive why this is a general formula. And if you refer to one of the old YouTube videos that's on the Knitex channel from last year that I had done, I explain why that is indeed the formula. Right, now I think it's time for us to move on. Let's go on to 2.2. In 2.2, we're given a quadratic number pattern. Right, in this number pattern, we are also given 4 terms and that sequence continues. This time we know it's quadratic. What is the formula for a quadratic number pattern? Do you remember? Okay, well, actually we don't. Here, we don't have to remember, it is given. There we go. We're told that the general term is given by Tn equals to an squared plus bn plus c. We need to now find out what A is, what B is, and what C is. So that's what we need to do. So I need to solve. I need to find A. That's the point of this question. B and C. That's what we need to do. And we are given the sequence, okay? So let me just remember this, minus 3, 6, 22, and 60. Right, I'm going to write it down below and we're going to perform the calculations. Let's see. Minus 3, 6. $27 and $60. Let's double check that I've taken it down correctly. Have I? Yes. So those are the terms, and now we need to perform. Well, what we need to do is we need to find out what is this. I need this, which means I need A, B, and C. Okay, now if it is a quadratic sequence, what property is being satisfied in here? Can you tell me? You were able to tell me that when it came to an arithmetic sequence, it meant that we had a common first difference. Great, so there's responses coming in. And here we know that when it's quadratic, we have a second difference, which is constant. Wonderful. So let's proceed to find out what is this second difference. So let's first calculate the first difference on the consecutive terms. Right, what values do you get? To get this difference, I need 6 minus 3. What is the difference there? That's just going to be 6 plus 3, which is 9. Isn't that so? What is 27 minus 6? That is 21. What is 60 minus 27? That gives me a value of 33. Are we all good at this point? Use your reactions to let me know that we're all happy with what's been written down. Okay, excellent. Now, let's continue. I need to find out the second difference. So let's repeat our procedure. So now I'm going to take 21 and I'm going to subtract 9. 21 minus 9 gives me a value of 12. Okay. And then if I take 33 and I subtract 21 from it, I also get 12. So do you see what's happened? What has happened? I've now found the second difference. And as you had told me, we've got a common second difference. So that is the actual property that helps us realize that the sequence we're working with is indeed quadratic. So we've got a common second difference. Okay, now, once again, by a previous video, I go into detail as to what each of these values here that I'm about to highlight represent. Okay, can you tell me what the 12 represents in terms of the coefficients that we're trying to solve for? Do you all remember these formulas? Chat box, wonderful. Everybody says it is 2a. Right, let's write that down. So we see that the 12 equals to 2a. What does the 9 equal to? Okay, I see everyone's trying to give us the question, the answer already. That's excellent. Right, so we've got 3a plus b. Okay. And what does our minus 3 represent? So obviously we all know these formulas, but these formulas come from somewhere. It is very important for you to know why it is 3a plus b, why it is 2a, and why the minus 3, as you just told me now, is equal to a plus b plus c. Okay. Of these things here can be generated by actually writing down T1, T2, and T3 and 4 based on this formula, right? So plug in 1 and write down what it represents. Plug in 2, write down what it represents. Plug in n equals to 3, write down what it represents. And likewise, plug in n equals to 4 and write down what it represents. Repeat the procedure of taking the first difference, right? Get the values in terms of the A, B's, and C's. And you will see that this 9 will be represented by 3a plus b. Likewise, complete the second difference. And when you do that, you will then see that the 12 is represented by 2a. So this is how we end up representing or knowing that the 9 is equal to 3a plus b, the 12 is equal to 2a, and the minus 3 is a plus b plus c. Because when you plug in n equals to 1, then you get a plus b plus c. And that's why minus 3 is a plus b plus c. Is everybody clear on what I had just explained? I know I explained it quite fast without physically writing down the stuff, but I want to give you a very quick idea because, of course, we are revising. We're not going through the theory. Okay, for you to understand what I said earlier is that I want you to understand. I want you to understand that, oops, let me sort that out. I want you to understand that 12 is 2a. I want you to understand why 9 is 3a plus b, and I want you to understand why minus 3 is a plus b plus c. And that derivation comes from looking at what is happening with Tn. Now, please go to the Knitex YouTube page and go to the term 1 videos that I had uploaded last year, and you will see me explaining how you get 2a, how you get 3a plus b, and how you get a plus b plus c. For now, let's assume that we understand and we know why these things equal, and let's proceed to solve for the A, for the B, and the C. Okay, so that's what I'm going to do. Right, so from the first equation, 2a equals to 12. So what does that now imply? That implies that A equals to 12 divided by 2, which is 6. So I've got the first bit. Then I've got 3A plus B equals to 9. Isn't that so? That's what I've got there. 3A plus B equals to 9, but I also know that A is 6 because I've just solved it, right? So that means I've got 3 times 6 plus B equals to 9. So what does that now tell me about B? So firstly, 3 times 6 is 18. So therefore, B equals to 9 minus 18. Do you agree? And therefore, B equals to, so let's come to the chat box. Lots of comments. Yep. Okay, you want to know about the YouTube channel? No problem, right? You're going to go and search Knitex. I'm putting it in the chat box right now. Knitex, right? And you're going to find it there, right? So you search Knitex on YouTube and you will come across the details. Okay, so everybody has now also given me the answer and they've told me that B is therefore clearly equal to -9. Okay, so now that's what I've got. And then the next step is to solve for C. A plus B plus C is -3. Let's solve that bit. Okay, I know what A is. A is 6. I know that B is -9. And I've got C equals to -3. 6 minus 9 gives me -3. Do you agree? And then if I add 3 to both sides, what do I then get? I then get that C equals to 0. Let's see. Chat box. Okay, very active. Wonderful. So we've got some answers coming in. A is 6, B is -9, C is 0. Wonderful. And then therefore, as you had already just pointed out, therefore Tn, which is given by an squared plus bn plus c, now equals to 6n squared. Sorry, this is an n, minus 9n plus 0. And that is precisely what we are looking for. Okay. Right, is everybody happy with the answer to this question? So, given a quadratic sequence, you then find the second difference equated to 2a, then take the first value from the first difference equated to 3a plus b, and take the first value from the original sequence and equate it to a plus b plus c. Solve for a, b, and c, substitute back in, and that is the solution that we arrive at. Okay, thank you for all of the reactions. Now, let's go on to the next part of the question. We've got loads more to answer. Calculate the value of the 50th term in the pattern. Okay, so this should be pretty straightforward, isn't that so? So I'm going to leave that to you to write down the last bit, but we want T50, isn't that so? So that's just 6 into 50 squared minus 9 times 50. All right, so I will leave that to you to put into your calculator and get out the final bit. Let's go to the next question. 2.2.3. Show that the sum of the first differences. So we have to be careful. Sum of the first differences can be given by Sn equals to 6n squared plus 3n. So we're not looking at the sum of the second difference. We're looking at the sum of the first difference. You have to be careful. Let's go back. Here is our first difference. Right, so this is the sequence with the first differences. Do you agree? It continues as well. First difference. And of course, if I wanted to generate the rest of the terms in this sequence, all I have to do is add 12 to 33 to get the next term, add 12 to the next term, and you continuously add 12 to generate all of the new terms in the sequence. So this is the first difference sequence that they're referring to. And what did the question say again? The question said, that we need to write down the sum of the first n terms. And isn't that easy to do? Let's look at chat box answers. Okay, I see you've all given me the T50. Thank you for that. Let's now talk about our sum to n terms. So we know that we're calculating the sum to n terms for this sequence here. That is what we're doing. Do we have a formula that you would have derived in school for the sum to n terms? Yes, you did. This was the formula, isn't that so? Sum to n terms. And this is the formula that you would use for an arithmetic sequence, okay? So that is very important. So this is the formula that we are now going to use. Okay. Is everybody clear on why we are calculating the sum to n terms using that formula? We are working in a quadratic sequence, but do you realize that they've asked us to work with the first difference? And what type of sequence is the first difference? Can you tell me? Right, lots of thumbs up, so that's good. The first difference sequence, as we had seen, is actually an arithmetic sequence, and therefore we use the formula for arithmetic sequences. So I'll just remind ourselves, we've got 9, 21, 33. Right, let's write it down here. And that question number was 2.2.3. Okay, so that's what we're looking at, and the sequence consists of 9, 21, 33. Okay, let's remind ourselves, 9, 21, 33, and the sequence continues. Good. So now I want the sum to n terms. I know that the A is equal to what? The A is equal to 9. I know that the common difference is equal to 12. That is what we saw. There we go. The difference between consecutive terms is 12. And so all it amounts for us to do is to plug everything in. So it's n over 2 into 2 times 9 plus n minus 1 into d. Right, let's continue. So that's n over 2. 2 times 9 is 18. Now we have to be careful. You need to distribute the 12 into the bracket. So that gives me 12n minus 12. You all happy with that one? I've just realized that I meant to write 2, but I wrote n. So that's n over 2. Okay, good. So now let's simplify what's happening inside this bracket. So I've got 18 minus 12. What does 18 minus 12 give me? 18 minus 12 gives me a value of 6 plus 12n. And now all you have to do is distribute the n over 2 into this bracket, right? So we get out that we end up with, okay, I'll write it out in full, right? So I've got 3 times n over 2 plus 12n into n over 2, and then we can simplify. Always dropping off the n. Okay, right, so just double check that I'm writing down everything correctly, right? So 12n multiplied into n over 2, that just gives me a value of 6n squared. Do you agree? We've got n times n, and 12 divided by 2 is 6. And then I've got 3 divided by 2. There's not much. Oh, let's see, why did I do that? Because I divided it. I was distributing. It was that multiplied to that, and that multiplied to that. Okay, so I think we're happy with the first term. 12n times n over 2 is 6n squared. And then we've got 6 divided by 2, which is 3 times n. Is everybody happy with that final solution? Okay. Yes, and luckily you all spotted that I wrote down the 3 instead of the 6 because I did the division first. So thanks for pointing that out in the chat box as well. Okay, I see lots of thumbs up. Everybody's happy with the solution. Okay, I'm very pleased that we're all following. So we've answered that part of the question. What's next? Right, the next part of the question says, how many consecutive first differences were added to the first term of the quadratic number pattern. Okay, so let's unpack that situation first, right? How many consecutive first differences? How many consecutive first differences? Okay, but we've just worked with the first differences, isn't that so? And they want to know how many were added. So they're talking about the sum of the first differences. So that means that this particular statement here, consecutive first differences being added, is the same thing as asking us about, if I convert that logically, it's asking me about Sn, the Sn that we calculated here, this one. We just saw it was 6n squared plus 3n, so we know what they're asking about. And they want to know how many, meaning for what n, and what n should I stop at when I add it to the first term of the quadratic number pattern. What is the first term of the quadratic number pattern? Can you tell me that? Okay, good. You told me -3. Do you all see that the first term of the quadratic number pattern, which is here, is -3? That was the first term. So that is what I need. I need the -3, right? The first term is -3. Right, so we want to know how many. So for what n should Sn being added to -3, right, allow us to obtain a value of 21,060. So let's read the question in full, word by word. How many consecutive first differences were added to the first term of the quadratic number pattern, which is -3, to obtain a term in the quadratic number pattern, meaning to obtain a term here in this sequence to the value of 21,060. So we want to solve for n. Okay, and that simply amounts to us solving the following. We want to know for what n is Sn being added to -3 equals to 21,060. Is everybody clear that that is the equation that I'm going to be solving? We want to know how many consecutive first differences are added, but we know that that is nothing but Sn when they're being added to the first term of the quadratic number pattern, but I saw that's -3. And then when I do this addition, I must get a value of 21,060. So they want to know how many. So I'm solving for the unknown, and the unknown is n. And that is what we are solving for. So let's solve this. Okay, let's now create a new page. Right, and this part of the question is 2.2.4. And we said we're solving Sn -3 equals to, I forgot the number, 21,060. Okay, then we also need to remind ourselves in what the Sn is. We just proved what the Sn is. We saw that Sn is equal to 6n squared plus 3n. Then we've got -3 equals to 21,060. Okay, so this is what we're solving for. I've got a constant in here, so let's see. Let me take that there. Okay, so I've got 6n squared plus 3n. And I'm going to end up with a value of -21,063. Do you agree? Is this true? Is everybody happy? All I've done is I've written it down as a quadratic expression, and now I'm going to solve for n. How should I go about doing this? Well, we can divide by 3. Isn't that so? Let's see. Then I get 2n squared plus n. I'm dividing by 3. Okay, and what is 21,063 divided by 3? Do I get a whole number? Okay, I see the chat box is lit up. Okay, I do see that someone says that they are confused. Someone wants to know, oh, is it a positive or is it a negative? So in order to go from this step to this step, I need to subtract 21,060 from both sides of the equation, don't I? So it becomes -3 minus 21,060, which is how I've got minus 21,063. Is that clear? Is the negative now clear? Okay, great. Right, and then I said we're dividing everything by 3. And so you've told me that this is supposed to be 7021. That's what I've got from everybody. Right, so I'm following what you said. Someone asked me to show them the question again. Here is our question. How many consecutive first differences were added to the first term of -3 to obtain a term in the quadratic number pattern of 21,060? And that is how we converted this word problem to solving that equation. Sn minus 3 equals to 21,060. That's what we're solving. That's what we've got. Okay. And so you could basically use the quadratic formula that says that minus b plus minus the square root of b squared minus 4ac over 2a will give you the roots. Okay, so then it's -1 plus minus the square root of 1 squared minus 4 into 2 into minus 7,021. Do you all agree with what I've written down? I've pulled out the a, the b, and that's my c, and I'm dividing by 2 times a, which is 2 times 2. What values do you get for n? Okay, great. I see everybody's following. Right, and I see that everyone says that we've got n equals to 59, or there's a negative part, right? Isn't that so? Let's write down both of them. Let's not ignore one of the answers. N equals to 59, or n equals to, what is the thing that I just saw? Minus 119 over 2. Is that correct? Okay, and of course, this one is not allowed, right? Because we cannot allow a negative value to represent the n. We saw at the beginning, when I did some explanations, that the n is a natural number. We are only going to consider the non-negative integers. So therefore, n equals to 59 is the value that we are looking for. And so n is the number of consecutive values that will be added in the SN. All right, so I hope everybody's understood that. How are we doing? Okay, right, so I think all good, lots of reactions coming in. Right, so let's move on. Here's the next question. Consider the following sequence. -11 is the first term, okay? T1 is that. 2 sine 3x is now T2, and 15 is T3. Determine the values of x restricted to the interval 0 to 90 degrees for which the sequence will be arithmetic. So again, I'm looking for a very specific type of property. The property is that there is going to be a common first difference. That's the thing in here. So because there is a common first difference, that means that this must happen. It means that when I take that difference, which is 2 sine 3x minus 11, which gives me plus 11. And when I take this difference, which is 15 minus 2 sine 3x, because it's an arithmetic sequence, the differences should be equal, right? So there is an equality sign between the two. And so because there's an equality sign between the two, it means that I can now equate these differences and I can solve for the unknown. What am I solving for? I'm solving for x. So let's proceed to do this. Okay, so if I do this, then I will add 2 sine of 3x to both sides, and therefore I get 4 sine 3x. Okay, do you agree? And okay, I'll just do it step by step. Plus 11 equals to 15. Is everybody happy with this? Okay, I'm getting some shocked emojis. I think that's a shocked emoji, right? So let's see. Why are we a bit shocked? So this is a very nice example. And why is this the case? Because now you've got your trigonometry suddenly merging with your understanding of how sequences behave, in particular arithmetic sequences. Now, it's a very natural thing to occur because you've also studied trigonometry in term 1. So you should expect things like this to pop up in the exam. But this is a very simple thing that we're doing. All we want to do is we're solving for x. Here's term 1, term 2, and term 3. We know that t2 minus t1 should equal to, that's a difference, should equal to t3 minus t2. And that's what I've done. Here is the first difference. Here is t2 minus t1. It is that value. And then t3 minus t2, here it is here, 15 minus 2 sine 3x. And they're equal to one another. And now all I'm doing is I'm solving for x. It's as simple as that. Are we all clear on this? Right, so I'm simply merging the theory of sequences, and we're now trying to investigate what is the value of x that satisfies this property. Right, so far from here, all I did was I added 2 sine 3x to both sides to get rid of the 2 sine x from that side. And now I want to ensure that I've only got constants on the right-hand side. So I'm going to subtract 11 from both sides. So if I subtract 11 from here, then I'm only left with 4 sine 3x. And then if I say 15 minus 11, then what am I left with? I'm left with 4. So now I see that sine of 3x equals to 1. Do we all agree? So now I want to know, so you can think of this inside. Think of this inside as a single value. Think of it as one thing. It's sine of something equals to 1, right? Think about it like that. Let's remind ourselves of what that sine graph actually looks like. So I'm going to do a very basic sketch in here. As you can see, my drawing is not that perfect, right? But you're going to get the idea about the shape and where the values belong. So the sine graph has a sinusoidal shape, right? That is the shape that we work with. We know it starts at 0 degrees, and this is 360 degrees. We know that that intersection is 180 degrees. And here, this peak, the high point in the graph happens at 90 degrees. And we know that that value, the high point for y equals to sine of x, is a value of 1. So sine of something attains a value of 1, right? So I'm going to highlight this thing here as green, right? Because this green and this green must technically be the same thing. So it's like you're replacing the 3x by x, right? So when is sine of something equal to 1? Well, the sine of something is equal to 1 at 90 degrees. Do you see that? So this happens. This implies that 3x equals to 90 degrees. Of course, the shape repeats itself, isn't that so? So it will attain 1 again at 360 plus 90 degrees, which is 450. But we will see that that is not required, because here we get x equals to 30 degrees, and this is clearly an element of 0, 90. Remember, our question restricted our attention. Our question said, you can only find for which x values in 0 to 90 degrees will this be an arithmetic sequence. And here we go. We found an x equals to 30 degrees that satisfies that we will get out an arithmetic sequence. And so the answer is x equals to 30. Okay, so I hope that we are all clear on that. Yes, so there's some questions here. Can you solve it like a general solution? Absolutely, right? There are various ways to solve the same problem. You can solve it in that way. Just ensure that your x value that you get in the end You restrict yourself, you pick the x that lies in 0 to 90 degrees. Okay, so it is solved exactly like a general solution. And I see lots of students had already answered 30 degrees before I got to it. So wonderful. I'm glad that you're all following. Okay, right. So let's see, what do we want to discuss next? All right, so here we now have a question. It says that R is 1/5 and A is 2000. So we already know in our mind when we learned the theory that R represents what? It represents a common ratio, isn't that so? And A represents the first term. So we know that this question here, even though they haven't mentioned it, but they should, is a question about geometric sequences. Okay, so we've got something about geometric sequences, and so we know that Tn is given by A times R raised to the power n minus 1. So that's exactly what we're going to use. It says, given that R is 1/5 and A is 2000, write down the general term. So therefore, Tn is going to equal to A, which is 2000, into R, which is 1/5, raised to the power n minus 1. And so that gives you 1 mark. Then it says calculate T7. Then all you do is say that T7 is going to be 2000 into 1/5, multiplied to 1/5, raised to the power 7 minus 1, which is 6. And I will then leave this to you to write down that final answer. Okay, now let's take a look. It then says, which term of the series will have a value of 16 divided by 15,625. So now we want to know, solve for n, which term, i.e. what is n? N is unknown. Which term in the series? Solve for n when 16 divided by 15,625 is equal to Tn. So let's do that. Tn equals to this. Is everybody clear on why I'm doing this? This is precisely what the question is asking. And we know that this is equal to 2000 Okay, good. Thanks for the reactions. All right, so now I'm going to need your help with your calculator. Let's divide both sides by 2000. Tell me, what do you get on the right-hand side? Divide both sides by 2000. Someone asks which question we're doing. Here we go. This is the question we're doing. Question 3. R is 1/5, A is 2000. And we're now doing 3.1.3. And I asked you to help me with the calculation. And here we go. We've got some solutions. You told me that this is now going to equal to 1 divided by 195.3125. Good, thank you. Right, good. So that's what we've got. So now basically what I've got is I've got b to the y equals to x, right? But this here happens if and only if log of base b, right, of x equals to y. So that is how I'm going to end up solving for this. That's what I want to solve for. Right, so this tells me, well, n minus 1 equals to log of 1/5. You've learned the logarithms. I heard you tell me that you did. Of this value here, 1 divided by 195.3125. So I'm just using this property of logs. Now, please help me again. Put this into your calculator and tell me, what is n minus 1 equal to? Right, great. Everybody says they know logs. So n minus 1, I want the value for n minus 1. I don't want the final answer. N minus 1 is equal to 9. Thank you. And therefore, n equals to 10. And so that is precisely how we're required to solve this question. And so it means that T10 equals to this precise value here. Okay, let's look at 3.2. I think this is the last question that we're going to be able to do before we conclude. So we're going to look at 3.2. Let's analyze what is 3.2 telling me. So 3.2 says that the sum of all of the terms, do you see this? This is the sum from n equals to 1 to infinity of Tn, but Tn is a geometric sequence. So when I take the sum from 1 to infinity of terms in a geometric sequence, what is that? Can you tell me what that is? Of course, this is a series. What type of series? You've seen this before? This is the sum to infinity, isn't that so? Right? So this is actually, this here is S infinity equals to 27. Do you agree? Based on your studies of geometric sequences, when you've got the sum of the terms from 1 to infinity, that is your S infinity. Good geometric series. So we've got S infinity, the sum of all terms is 27, and S3 is 26. So let's write that down. Okay, so I've got sum to infinity is 27, and S3, did I copy that correctly? Is 26. Right, so this is what I've got. Now, if we go and remind ourselves about the things that appear in the formula sheet, here we go. This was the stuff that appears in the formula sheet. Right, sum to infinity tells you, in particular, when you're summing all of the terms, then that formula is represented by A divided by 1 over R, and the R is between -1 and +1. So that's what we're going to be using. Right, let's follow this. So that means in this situation that what I've got is A divided by 1 minus R equals to 27. And more importantly, I know that R is between -1 and 1, which means that this formula here is going to be given by, what is that one going to be given by? You'll remember? This is also in your formula sheet. So how do we write that one down? This is going to be, let's see, let me try and pull up that formula again. Right, so here is the sum to n terms, right? Because we want S3. So I'm going to use that formula. Okay, let's go back and write down what the S3 represents. Right, so S3 represents A into 1 minus R to the power 3 divided by 1 minus R equals to 26. Are we all happy with the formula that I've written down? Do you agree that this is S3 using the formula? Good. So now this is what I have, and let's go and remind ourselves about what the question's asking. Well, what is the question asking? It says calculate the value of the ratio. So I now want to solve for R. So let's solve for R. Okay, so I'm going to use this bit. I'm going to solve using this. Right, so this tells me, well, this is A into 1 minus R times 1 minus R cubed equals to 26. Does everybody agree with what I've written down? Do you agree that this here is precisely what I've written down here? Good. But what is A divided by 1 minus R? Do you see that it is 27? So this then tells me that 27 into 1 minus R cubed equals to 26. Look at that. And so if I continue with my calculation, this now tells me that 27 minus 27R cubed equals to 26. Okay, but actually, did I need to put that out like that? Oh, yeah. Okay, that's fine. So now I've got my negative 27R cubed, and I'm going to now subtract 27 from both sides. Do you see I get -1? And so now if I divide both sides by -27, I see that r cubed is equal to 1 over 27 because the negative signs cancel out. Do you all agree? And so can you tell me what r now equals to? What is the cube root of 1 over 27? Great. And so we see that r is now going to equal to 1/3. Does this satisfy the criteria that we had set out for ourselves? Yes, because we saw that r must be a value between -1 and +1. And so that is how we get to this solution. Okay, and so I think this is an appropriate time for me to stop. This video will be available on the YouTube channel, and we will make the notes available to all who attended. Before we end, I would just like to make you aware of the following opportunity. The International Day of Mathematics is going to be celebrated on the 11th of March, on a Saturday morning, 9 a.m. to 11 a.m. It's going to feature wonderful activities, amazing talks by mathematicians across South Africa, and opportunities for you to win prizes. So if you can just go to the social media, you can go to my social media, Facebook, Instagram, you can go to the Knitex webpage and their social media, or any of the partners that are included here on this flyer, and you will find all of the details for the upcoming competition. You can submit a meme, a mathematics meme, and the best meme with the best explanation will win a cash prize, as well as if you participate in a live quiz on the day, you will also get another opportunity to win a cash prize. So what I'm going to do is I'm going to quickly give you the registration details in the chat box so that you can register to join the event. But other than that, I just want to thank you all for joining, and I hope that you found this session extremely useful. Okay, so